Hello, we are discussing about GATE 2011 ECE paper. Look at the root locus plot given for a system. Find the open loop transfer function from that one. Okay. We know that one root locus plot is a graphical technique used to know how the roots of characteristic equation, which are nothing but poles of closed loop transfer function, changes with variation of certain system parameter. Generally, we will take it as gain itself. So root locus is a plot of graphical technique and which gives the information about the variation of closed loop poles, that is change of closed loop pole location as gain changes. And root locus plot is generally made up of root locus branches, and each root locus branch start at open loop pole and ends at either finite open loop 0 or at 0 at infinite. And number of root locus branches will be always equal to number of open loop poles. So first we will find out how many number of open loop poles are there, and from that one we will see how many number of branches are there. From that one you are going to get the transfer function. Okay. So generally pole is indicated with a cross mark and 0 is indicated with a circle. Now with the help of root locus branches, number of root locus branches is equal to number of open loop poles. Root locus branches can be identified. They will start from a pole and they will end at either finite 0, finite open loop 0, or they may end up at infinity, that is 0 at infinity. So we will start with the arrow which is going to be originating from pole. So if you observe, this is the first arrow which is starting from this pole and it is ending at this 0. So this is first root locus branch. So this is P1 say, and it is Z1, 1 open loop 0. And if you are observing, this is second arrow which is originating from a pole. Okay, because root locus branch always starts from open loop pole and ends at 0, finite open loop 0 or 0 at infinity. So now if you are observing this one, these are the two root locus branches, that is second one as well as third one. This is 2 and it is 3. They are originating from the poles and one is moving towards positive side, the other is moving towards negative side. Okay, we cannot say whether which is moving towards which side. So these are the two root locus branches. They are going towards infinity. They will go in this direction towards infinity. And next one more arrow is also starting from -3 which is going towards minus infinity. So this is fourth root locus branch. So there are 4 root locus branches present in the circuit. Definitely there will be 4 open loop poles. If you assume it as P1, then this will be P2 and it will be P3 and this will be one more P4, because even though there is a single cross mark is indicated, but with the help of arrows we can say there is a double pole at -3. So there will be 2 poles present at -3. So now we will write the pole locations. Open loop pole locations. First one is at origin P1 and second one is P2 is at -2 and third one is at -3, fourth one is also at -3. 4 open loop poles and only one open loop 0 location, that is only one which is at -1. So the general root locus general transfer function equation from the root locus can be written like this: g of j omega into h of j omega. From this one open loop transfer function you can write it as s plus z1 into s plus z2 divided by into s plus, this is general transfer function, s plus p2 dash 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 and into system gain k. So from this one you have only 1 0, so we can write it as k into s plus 1 because 0 location is at -1 divided by, First pole location is at origin, second pole location is at plus minus 2, that is s plus 2, and third pole is double pole at minus 3. So this is the transfer function for the given plot. K into s plus 1 by s into s plus 2 into s plus 3 whole square. So the right answer is B. B is the right answer for the given question. Thank you.